Okay, now on to 7.2. So everything on the back of this worksheet is 7.2, which is finding all zeros. Those could be complex, so those could have imaginary numbers. We might have irrational zeros. So we're finding all zeros here. Okay, so when you look at these polynomials, ask yourself first, how can I factor these? To find your zeros or your roots, you need a factored polynomial. So this first one I see is two terms. Now when you have two terms, you ask yourself, is it a difference or sum of cubes, or is it a difference of squares? Well, this one is a sum of cubes. My a value here is x, and my b value here is 1. So I can factor that as a sum of cubes. So f of x equals my a plus b, so x plus 1, and then a squared, which is x squared, plus ab, oh, sorry, that should be subtraction, minus ab, so minus 1x, plus b squared, so plus 1. Okay, so I've already got one factor. I know 1, 0 is the number 1, so I'm going to write that down here. Zeros, I already know one of them is negative 1. Okay, I still need to factor this. So let's see if I can use guess and check. Well, positive 1 and positive 1 wouldn't give me negative 1, and negative 1 and negative 1 wouldn't give me negative 1. So I cannot use guess and check here. So instead, I have to use my quadratic formula. So off to the side, I'm going to write my quadratic formula for this quadratic. So it's negative b, well, b is already negative, so that's positive 1, plus or minus the square root of b squared, so that's negative 1 squared, minus 4ac all over 2a, which is just 2 times 1. Okay, so this gives me 1 plus or minus. Under the radical, I have a 1 minus 4. That's a negative 3 all over 2. Now I'm running out of room, so I'm going to write this right here. If I have the square root of negative 3, well, that's the same thing as 1 plus or minus the square root of 3 times negative 1 all over 2. I can take the square root of negative 1. That's I. That's our imaginary number. So this is 1 plus or minus I root 3 over 2. So these are our other two zeros. Okay, so our zeros are negative 1, 1 plus I root 3 over 2, and 1 minus I root 3 over 2. And then you're done. You found all your zeros. Let me square that off, and we'll try the next one. Number 8. Okay, so this one is not a difference of squares or cubes, and it's not a sum of cubes. We've got 4 terms here. Now we could try to group, but just right off the bat, I can see I'm not going to get any common factors there if I try to group. So instead, I'm going to try to find all my possible rational roots. That's a good place to start. I know a bunch of numbers that could be roots. So remember, that's all the factors of 45 over all the factors of 2. Now, just for the purposes of this problem, usually we won't have numbers this high. I will tell you, you're going to try either negative 5 or positive 5. So if you want to try that on your own, pause the video now. And then if you just want to watch me do this, I'm going to tell you that negative 5 is definitely a root. So I'm going to show you why. We're going to do synthetic division. And we're going to try this out. So write your coefficients. And then let's do synthetic. So bring down the 2, multiply, and add. Multiply, and add. It's 5, 9. And multiply, and add. Okay, so we get a remainder of 0 there, so negative 5 worked. If you had tried a different number, you would have gotten a remainder, and then you would have kept trying your numbers until you tried negative 5. Okay, so this polynomial can now be written as x plus 5, and then remember, use these numbers as your new coefficients. 2x squared plus 7x plus 9. And then from here, now you can use the slip and slide, but since we're practicing using our quadratic formula, let's use that instead. So I'm going to start that over here, use quadratic, and we're going to find the zeros of this using our quadratic. So that is negative b plus or minus the square root of b squared, that's 49, minus 4ac all over 2a. So that's 4, because a was 2. Okay, so I'm going to run out of a little room here. Okay, so this is negative 7 plus or minus, and then we've got 49 minus, well, this is 4 times 2, that's 8 times 9. If we subtract these, then we should get 23 in the under the radical. Let's see if I'm doing that right. Hold on. Calculation time. (49 minus). Okay, good. So under the radical, if I do this subtraction, I should get negative 23 over 4. And then don't forget, you can always take the square root of a negative 1. So this is negative 7 plus or minus I root 23 all over 4. This, while it is this big number, this is the positive and negative version of the zeros. So we've got the 0 of negative 5. So zeros, negative 5, and then negative 7 plus or minus I root 23 all over 4. Okay, so that's 3 zeros total. All right, next one. Now this is going to take factoring out a greatest common factor first, because I see both of these have an x. So I can actually factor out, I'm going to factor out a negative x. I want this 27 to be positive. So I'm going to factor out a negative x, and then what's left is 27x to the third minus 1. Now I see this is a difference of cubes. So I can factor this as my a value here is 3x, my b value here is 1. So this is 3x minus 1, and then 9x squared plus 3x plus 1. Now I have 1 0, that's the number 0. I have another 1/3, so I'll start writing those down here. 0, 1/3, and then we're going to use quadratic for the last two. So again, set up your quadratic, negative 3 plus or minus the square root of b squared minus 4ac all over 2a, that's 2 times 9. And then I'm just going to skip a step here, so this is going to give me negative 3 plus or minus 3i root 3 all over 18. And then you'll notice that this negative 3, this 3, and this 18 all have a common factor of 3. So I'm going to divide all 3 by 3. That will give me negative 1 plus or minus I root 3 all over 6. So those are your remaining zeros. So negative 1 plus or minus I root 3 all over 6. All right, last one. Well, I can't use my difference of cubes or squares or difference or sum of cubes, and I could try to group. Let's try to group. Let's see what happens here. So if I group here, well, I can factor out an x squared here, and then what's left is an x plus 1. And then here I can factor out a negative 1, so minus 1, and then that leaves me 3x plus 1. What am I forgetting? Oh yeah, when I factored out an x squared from 3x to the third, I should have had 3x there. Okay, so now this means I can group here. So using my grouping rules, I can group x squared and negative 1. And then I'm going to write this one that they have in common, 3x plus 1. So I already have one of the zeros. I already know negative 1/3 is already a 0. So I'm going to write that off to the side. Negative 1/3. Okay, I've got 2 more to go because this is an x to the third polynomial. Look at here. I have a difference of squares. X squared and 1 are both squares. So this factors as x plus 1, x minus 1, and then don't forget we still have the 3x plus 1. So this one actually didn't require any quadratic formula. So my other zeros are positive and negative 1. You could have used quadratic formula here. You'd still get the same answer. It just would be a little more work. I'm just going to cut off that work from the other problem. Okay, and then last on this page, all we have to do is write a polynomial of the least degree with the zeros that are given. Now don't forget, our complex roots always come in conjugate pairs. So I'm first off going to go through these problems and write any zeros that might have been left off. For this first one, if root 5, that's irrational, is a 0, then so is negative root 5. On number 12, if root 2 is a 0 or a root, then so is negative root 2. On number 13, well, I already have a conjugate pair, that's these ones right here, but then 2 plus I needs its negative opposite, its conjugate pair, so I also have to do 2 minus I. And then last one, none of these are irrational or imaginary. They're not complex, so they do not have pairs that I need to add on to. Okay, so let's go back and let's write our polynomial with the given zeros. So I'm just going to write these as f of x. You can also do y. And if 5 is a 0, then x minus 5 is a factor. If root 5 is a 0, then x minus root 5 is your factor. And then for negative root 5, you're going to do x plus, just like that. Now in other classes or for other days, we are going to multiply these out and actually write it in standard form. But for now, we're just going to leave it in factored form. Okay, number 12. Let's go through again. F of x equals. We're going to do the first 0, so that's x minus 2. X subtract root 2. And x plus root 2. So number 11 and 12 were both cubic functions. Those were both polynomials with x to the third as the highest degree. Okay, number 13, we've got 4 zeros here, so we should have 4 factors. This time I'm going to write y equals, just for funsies. So this time I'm going to take x minus, and then since there's more than one term here, I'm going to put it in parentheses, so 2 minus 3i. Then our next one, x minus 2 plus 3i, and we'll just do that for all of these. X minus 2 plus I, and x minus 2 minus I. Now, if we just want to make this look a little nicer, what we're going to do is distribute that negative. So this is x minus 2 plus 3i, x minus 2 minus 3i, x minus 2 minus I, and x minus 2 plus I. So I just basically got rid of some of the parentheses. All right, last one. This one's really simple. Y equals x plus 1, x minus 2, and x plus 2. And that's it. Again, we can multiply all of these together and write our polynomial in standard form, but just not for now, not for this worksheet. Okay, thanks for watching, guys.